Dzień dobry, Krakow. My name is Thomas Steiner. I'm based out of the Hamburg, Germany office, and I work on mobile web stuff, mostly with big partners. And with me today is my guest speaker, Steven. Steven, do you want to come up and introduce yourself?
Hi, so I'm Steven. I'm a product manager at Google in California, and I'm just visiting, guest speaking today on the topic of identity and authentication on the mobile web.
Thank you. So today we want to show you what's next for the web, or as an alternative title, exploring about flags. But before we get started, here's a fair warning. There's a lot of content coming, and I'm going to speak fast, probably even too fast. So hold on to your seats, and especially watch out for all the links. So many of the slides have links, and of course, you can just snap a photo of the slides so you can look up some of the content after the presentation. So let's get going. Let's get started. Our first big topic area is progressive web apps, or short, PWAs. Let me show you how you can, with PWAs, create immersive full-screen experiences, because your apps deserve a lot of screen real estate. So some of you may remember from I/O 2016, the Paper Planes World app. It's actually still up, paperplanes.world. If you go online, you can test this app. And if you launch this application, you might notice something. This is a web app, but if you look at the screen at the top, there is no network signal, no clock, no battery status indication. It's a true, fully immersive, full-screen experience. And you can do this by setting the display property in your web app manifest to the value of full screen. Pretty new, very exciting for game developers. And yeah, hopefully you try it out for your application. For PWAs, we also have an improved add-to-home screen experience. When users install the PWA, they will now be able to find PWAs in the Android app drawer, just within all your other native applications. So they look and behave and finally react as true native applications. So you can just search for your app, find it in your app drawer. And this is something that a lot of developers have really been looking forward to. You can now also update the icon and change the application name after your application is installed. And something that's really cool as well is with the improved flow, you can now, based on the scope attribute that you give in the Android, in the web app manifest, create an Android intent filter that allows you to react whenever your URL pattern within the scope is hit. So your application can just open directly whenever it is being mentioned somewhere in a chat, for example, and then directly go into the PWA experience. The next thing is the Web Share API, because we all do know that sharing is caring. And if you want to do that on pretty much any site in 2017, you end up with an experience like the one that you can see on this slide. So a lot of screen real estate is, in a sense, wasted for all these sharing buttons. And of course, looking at the sharing buttons, always the one social network that you actually would want to share on is not on the list. And as we have seen in the previous slide, with the full screen experience, sometimes also just the URL bar is hidden, so you need a different way of sharing your application. And this brings me to the Web Share API. It's directly integrated with the native Android sharing dialog, which is really cool, because there you have a truly native experience of sharing your content. So if you look at this code snippet, it's very short, navigator.share, and then you can give a title, you can give a text, and you can give a URL. And this allows you to change the URL that is displayed on the screen. So for example, when you think of something that is hosted somewhere or embedded in an app cache, for example. The next topic is push notifications. And actually, the next thing is mostly interesting or only interesting for macOS users, because finally, on macOS, the notifications are integrated directly in the native system notification center. So they no longer feel like strangers. They're now just native notifications, which also means they respect your devices or your system's do not disturb setting, which is super, super powerful, of course, because you don't want to be disturbed by notifications when you give a presentation, for example. So now, finally, this is possible. So the next topic is kind of an interesting topic. Some companies ship down 3 megabytes of image data and then shrink it down on the client side, and other companies have worries about performance of the service worker, so service worker boot time being too long. So this is a pretty exciting new API, or it's an origin trial, actually. Navigation Preload. What this does is it kind of makes the time where the service worker boots up not waiting time, but parallel time that your app can already use for navigation request. So if you look at this little diagram here down at the bottom of the slides, you can see the service worker boot time before and the service worker boot time after this trial is activated. So you can see it's running in parallel, so the request can already happen. So how do you use that? If you look at this code, you can see there's 2 events, the activate event and the fetch event. In the activate event, with this highlighted yellow line, await self-registration navigation preload.enable, you enable navigation preload. And then in your fetch listener, after going through the chain of do I have the cached response, no or yes, you can then check if maybe there is a preloaded response available that you can then directly ship to the user. So this allows you to get content to the user faster without waiting time for the service worker to boot. On mobile, you now have a pretty exciting new way of signing up. And for this, let me bring Steven on stage.
OK, thanks, Thomas. So what we'll talk about here is one part of the experience of building a mobile web app that is often frustrating. And it's only a small part, but it's often a big problem that developers encounter. And that is how to get people signed in and signed up on such a small screen. We probably all had experiences that look like this before, where you have to remember username, password, type it in on a mobile keyboard. And perhaps you've added something like Google sign in or Facebook login to your app, but there aren't people using it. There's always been a concern about what data gets shared, how these work on the mobile browser, and how you'll end up back on the site. So what my team has been thinking about at Google is ways to improve this experience for the mobile browsers that are out there. And what we are working on right now is a new and unreleased API. It adds an iframe to your mobile site where you can offer a one-tap sign-up or sign-in experience. This gets someone into your site or signed up through checkout or conversion flows with as little friction as possible. And as a new thing, we'd love to hear the feedback from developers like you on how this might fit into your site. So check out the link or send me an email. Stick around for questions after to discuss more and send us feedback on this part of the mobile web experience. Thank you.
So how can you use that? Essentially, there's 2 API calls that you can make. For auto sign-in, you can use smartlog.retrieve. And for auto sign-up, you can use smartlog.hint with a couple of configuration things. So as I said, you're not supposed to understand this code in this short time. This is just for you to get an idea about what is possible or will be possible pretty soon. So let's get back to PWAs in general. A question that we get a lot when people develop a PWA and we talk about cache is, well, what even am I allowed to use? Like, how much storage do I have? Or if they already have a cache and it's full with content, or somewhat full with content, they're wondering, well, how much of my cache am I actually already using? So with the new storage estimation API, you can now find out. So you just very easily call navigator.storage.estimate, and then when the promise fulfills, you get data about how much storage you're already using and how much storage is available in total. So super useful feature, a long time thing that was awaited very, very eagerly by developers of PWA. So let's move on to the next big topic area, which is media-related APIs. Media on the web is very exciting. And the first API that I want to talk about is the image capture API, because you should be zooming in on what matters. So on the screenshot, you can see what matters is my face. So I'm zooming in on my face in this stupid animation that I created for this slide. So this API allows you to actually natively zoom in. So this is not software enlarged. This is a native zoom of the camera. And you can use this directly from your browser. And this is how you do it. So for this little demo here, you can see the slider. And the slider does need to know, of course, how much can it slide. So what is the maximum zoom level, essentially? And you can see in this short snippet of code how from a media stream, I first get the video track, the first one, and check its capabilities. And from the capabilities, from the track, I check the available settings. And then I can use that to update and create my user interface. And like this, allow the user to zoom in with the capabilities of the device directly being used and being applied. So that's pretty cool, pretty exciting. Something even cooler and even more exciting is the shape detection API that allows you to detect faces, read barcodes, and even to run optical character recognition, OCR, right in the browser. You can see this little demo here. I was just holding my phone and pointing to different browser tabs where I had open first a QR code, and then on the second tab, a face and some text here. So you can see how, in real time, the API detects the different objects on this page. So this is directly integrated in the browser. So let me quickly show you how it works. You first need to initialize the different detectors, so the face detector, the text detector, and the barcode detector. And then you can just listen for events. So everything is promise-based, so you can queue up all the different promises, face detector, .detect, text detector, .detect, and so on. And then you will get the detected objects in the results. So pretty cool, super easy to use. If you check out this demo, you will see it's 100 lines of code and everything directly working and running in the browser. So super exciting, super cool API. I think this unlocks a lot of cool new applications. The next thing is the media session API. When you play media content on the web, you want to know, of course, well, what is playing, when is it playing, and on a mobile device, you, of course, want to control. You want to skip forward, go to the next track, pause. This is all possible now with the media session API. You can see meta information of the currently playing media, and you can, of course, directly control it. So let me show you as well how this works, and first, what kind of metadata you can control. So in the screenshot here, you can see there's a title, there's an artist, there's an album, there's artwork, and then you have the different action handlers that you can set. So seek backward, previous track, and so on. So a lot of things possible. And this block of code might first look pretty intimidating, but actually it's just two big things. On the first half, I'm just setting here all the different media metadata in the object. And then at the second half, I'm just connecting the different action handlers and connecting functions to the different events. So super easy to use. Again, very powerful, great integration in the native operating system. WebVR, big topic, super cool thing, because sometimes the real reality actually is not real enough. So WebVR allows you to create compelling VR experiences right in the browser. It's an open standard that just allows you to directly program these kind of experiences so that everyone can get VR experiences very easily. On this demo created by Martin Split, you can see how this could change the lives for interior designers, for example, who could just pass on a link to the work that they've created to their clients. They don't have to install any native 3D viewer software or anything. They can just take out their VR goggles, cardboards, whatever, and just have a quick look at how their future home might look. Super cool, directly in the browser. Performance. This is super important, of course. We preach performance a lot. performance-related APIs no longer allow you to have an excuse for having a bad performing site. Network Information API is something that you can use to know how fast you can go. Let me show you what you can do here. So based on the connection type of the user, you can now adopt your experience. So for example, you could show someone low-resolution image assets when they are on a slow connection. And you can, of course, also be on mobile in a true mobile way. So sometimes you're in a tunnel, sometimes you are, I don't know, somewhere in the countryside, and then sometimes you are just in the city. So what I'm getting at is connections change. So of course you don't want to have someone with a low-res experience for the entire session, but sometimes when they have a good connection, you of course want to give them high-res images. And you can see here in this code how you can first of all just read out the information, but then of course be notified when the connection changes. Why is this important? Well, you of course have media queries. So you could say, well, this user is on a Retina display, super high resolution capable, but actually combined with network information, it might after all not make sense to show them super high resolution images. So this is just a short example how you can programmatically from JavaScript query media queries, check for the result, and then combine it with the connection API to see, well, is the connection actually right now good enough for supporting high-res images? So you can directly work with media queries and with the connection API together. Then there's the core performance API, because you do care, or should be caring, what's happening when a page loads. For this, I was very quickly auditing the actual event page for the GDD. So there's a lot of different things that you can get and calculate dynamically. So you can see here, I'm getting the perf data from the window.performance.timing object. And then you can calculate a number of things, like, for example, the page load time, or the connect time, or the render time. And these are core metrics that you could then just simply report back to your analytics backend. And like this, you could see how do real users in the real world out there experience my page. And if you then see alarming numbers, then it's probably a good idea to get going and improve your site and make it load faster or render faster. So that's really cool. But then, this is only one part of the story. Something more interesting and more important, actually, is making sure that content in a meaningful way gets to the user. So what you can do now is, with the paint timing API, information about key painting events. So when did what content arrive at the user's device? And there's even a performance observer, so you can get dynamically notified and react whenever a certain paint event happens. So I was auditing this page on a simulated slow 3G connection, and you can see here in the console, it's relatively small, I think, but you can still maybe see it, the first paint and the first contentful paint. So when was the first moment where something, no matter what, was painted? And when was the first moment where something meaningful was painted? So for example, text, for example, an image, so that people can actually consume content and not just stare at a gray background or a white background. So super useful API, and of course, this is core metrics. These are core metrics that you can then again report back to your analytics and see if everything is okay. Client hints, also very exciting topic. That allows you to adopt and see what kind of device you have to do with. We have in Chrome telemetry, so we kind of get a feeling of what's going on with the browser. And we've noticed that a lot of foreground tab crashes are actually due to out-of-memory exceptions. So when the device runs out of memory, the Chrome tab might crash. So you can see here an Android phone more on the cheaper end of the spectrum. So for these kind of devices, it might be a good idea to maybe not serve super high-res, super RAM heavy experiences, but maybe adopt it. So how can that work? First of all, servers can advertise that they support client hints. For this, there's a new HTTP header called accept-ch, so ch for client hints, and then you can provide a list of the different client hints that your server actually supports, in this case, device memory. And clients can then, so user agents can then send the device memory, for example, and say, by the way, I'm a poorish device, I have 0.5 gigs of RAM only, so that then the server can adapt the experience accordingly. And also, you can read out this information on the client side with JavaScript. So you can just have a look at navigator.deviceMemory and see what is the actual hardware device memory right now. And you can also see how many cores does the CPU have. So when you kind of program a game, for example, you can decide, should I use the heavy textures or should I use the lighter textures, dependent on device memory or the hardware concurrency. So how many cores does the CPU have? Super exciting, great new features. Which then brings us to hardware-related APIs. The first API that I want to mention is the Web Bluetooth API, which allows you to communicate with nearby Bluetooth devices. In this demo here, created by François Beaufort, you can see how, with his phone, he's controlling Bluetooth candles. I wasn't sure that this kind of thing exists, but actually it does exist, Bluetooth candles. And you can see here why this could be fun. You can just allow anyone with a device that is in range to control the experience here. It's using the GET, so generic attribute profile, and uses Bluetooth 4, so very energy efficient. It's partially implemented in Chrome on Android, Linux, macOS, and in Chrome OS. Very exciting API. The next thing is WebUSB, which allows you, well, as the name suggests, to expose USB devices directly to websites. This is, of course, not for any and all USB devices, but for USB devices that were specifically designed for that. In this demo here, created by Kenneth Road Christiansen, you can see how he's using WebUSB to talk to an Arduino board to then display text on a dot matrix screen. So these devices need to be specifically designed for being used on the web, and it's obviously HTTPS only. So this is a very powerful API. So we want to be sure that this is HTTPS only, and of course it has to be user-initiated. So you can't just silently, secretly connect to a USB device. It's always after a user gesture. Again, implemented in Chrome on Android, Linux, macOS, and in Chrome OS. And today, there's one more thing. Today, we're launching Scaasi, which allows you to revive your old Scaasi hard disks, bringing the 80s back to the web. Scaasi is a small computer system interface, a set of standards for transferring data between computers and peripheral devices. Scaasi emulates a Scaasi controller right in the browser and defines interfaces for access. It's landed in Chromium 64 technology preview Canary Nightly. Very excited about that. This was, of course, a joke. But what I was getting at, this is not the end. This is just the beginning. The web is so great. The web is ever evolving. And if you want to stay up to date, we very much invite you to subscribe to developers.google.com/web/updates and be notified of all the new great things that are coming. With that, Jen Kuye, Thomas Steiner, and Steven Sonnet.